Hi, I'm Andrew Connell, and in this screencast we're going to look at a deep dive into the Office 365 API for Mail. Before we begin, let's look at the developer vision for the Office 365 development. It boils down to both users and data. What do I mean by users? Users want to be able to work with their devices and interact with all of their information using custom applications or some of the applications that have been provided by Microsoft, such as the Office clients as Word, Excel, Outlook, and PowerPoint, as well as custom applications that developers build. They want to work with them in a familiar environment with familiar user interfaces. For developers, we want to be able to build custom applications using a multitude of different platforms, from working in a mobile experience to working off a server-side product, or something that's working on the desktop, or even just a standard web page. We want to be able to get to all of our data and provide these really good experiences for our users. We'll first look at an overview of the API, understand what the connected services are, how to do paging, how to do batching, how to do the different CRUD operations as create, read, and update, and delete, and then some Exchange operations using the REST API. We'll start with an overview. The Office 365 APIs for calendar, mail, and contacts are all very similar. We have access to them through the outlook.office365.com endpoint. Specifically for mail, it's going to be /API/v1.0/me/messages. The Office 365 APIs are accessible through the Outlook Services Client API. This is a .NET object that is going to abstract away the sending and receiving of REST requests to the endpoints. To work with email, or we're going to call them messages in the API, we have a couple different common API operations. We can read emails, we can find emails, and we can send them. Before we do that, we need to talk about connected services though. A connected service is something you're going to add to your .NET project within Visual Studio. You're going to select the project, right-click, and say Add Connected Service. This is going to allow you to very easily create a new application in Azure AD. Once you've registered your app, you're then going to assign your application permissions. And you can do that by selecting the different services, in this case Mail, and then check the boxes for what we can actually do. Once you've added a connected service to your project, a couple assemblies will be added for you when you complete the wizard. The Microsoft.Office365.OAuth reference, you'll have a reference to OAuth.web and a reference to Outlook services. The app settings that will be added to the web config from the connected service dialog will give the code that's provided access to your client ID and password for your application in Azure AD, as well as the authorization URI and the redirect URI that's required. This snippet of code is going to be very similar in most of the applications you write. Now in this case, this is working with the calendar endpoint, but it would work the exact same with messages. If you look towards the middle of the page, you'll see a comment that says Create Auth Context. The authorization context is a class from within the Azure AD authentication library, or the ADAL library. This is going to be used to create an authorization context or an authentication context to get an access token to use to call the different endpoints. So here I'm passing in the authority, and I'm also passing in an object called a token cache. Now the token cache object is going to allow me to cache the different OAuth tokens that I get back from Azure AD, so that in the future I don't have to make the round trip to get a new access token when I want to query the API at a later date. So in this case here, I'm using the Entity Framework. I'm using an Entity Framework ADAL token cache that stores the tokens in a local database using Entity Framework. But I could be using something like Redis cache or a session state or really whatever else I wanted to use. Once I've created that authorization context, I then need to use the Office 365 Discovery Service to find out the endpoint for my email. So what I would do here is create an instance of the Discovery client, pass in the well-known endpoint for the Discovery service, and then I need to also pass in the access token. And I get the access token by calling authcontext.acquireTokenSilentAsync, and then pass in the ID of the Discovery service, the credentials for the current application, that's the client credentials, and then the user identifier. Now, the the acquire token silent async method, what this is going to do is it knows to look inside the token cache to see if I already have the token. If I do have a token, then it will return that back. If the token is expired or is about to expire, it'll use the token and the refresh token that's been stored in cache to go out to Azure AD to get an updated token and store that in the cache. And if it doesn't have one at all, it knows to go straight to Azure AD to obtain the token and then save it. Once it's done that and it gets the access token, it'll return that back. Then we can use that in the creation of the discovery client. I'm then going to query the discovery service by creating a capability discovery result by calling discovery.discoverCapabilityAsync. I'm then going to pass in this case here it shows calendar, but I'm really passing in messages for the mail API to get a reference to our capability. I'll then use that object that's created. It's going to have two things that I'm interested in: the endpoint to my mail and the resource ID for that endpoint. So then I'll create an Outlook Services client object, passing in the endpoint, and then I need to get the access token for that endpoint. And I'm doing that the exact same way I did above with the discovery service. I'm going to go to the authorization context, call acquire token silent async, get the resource ID, the credentials for the app, and the current user to get the access token and return that back to the user or to the application. Now, programming with the Outlook Services client is actually very easy. Once I've obtained one, I'm then just going to say client.me, client being the Outlook Services client, client.me, me pointing to my resources, and then I say .messages, and then to get a specific message, I just say get by ID, pass in the ID of that message, and then execute async to get the data back. The next thing I want to do is I want to retrieve some messages. So how do I do that? Well, you can see at the top, I'm going to get a reference to the client context, and then I'm going to go make a query for all the information, and then I'm going to say skip and take. Now that's going to be used for paging, and we'll look at that in a few minutes. So I'm saying go for each message, look at the client.me.messages, sort them by time sent in descending order, and select the message, execute async. I'm then going to get a list of all the messages, and then I'm going to walk through all the messages that I got back on the current page, and I'm going to convert those to my own object that you see I've defined here on the right-hand side. I'm going to use that as my model for my views inside of my MVC application. Let's take a look at a demo of this in action. In this demo, I want to show you how to take an existing MVC project and add a connected service to it. So we can see here that my app has already been set up with a couple settings that are not set yet. So client ID, password, Azure AD tenant, and the authorization URL. So what I want to do is add a connected service. So I'm going to right click on the project and say add connected service. Now, I want to go first and register my app. So I'm already logged into Azure AD, so I'll click on register my app. And that's going to create a new app in Office 365's directory in Azure AD. So now what I'll do is let's go into the properties for the app. Now I'm going to go modify the properties so that I'm only going to have this app listen on an HTTPS endpoint. So we're going to need to grab that URL, and we're going to need to do something with that in just a minute. It's also a single tenant app. Now I'm going to modify the permissions to give my users access to sign in using the app, and then also to access their mail. So I'll check off these three different permissions for mail. I'll go ahead and save my changes. And what Visual Studio is going to do now is add a NuGet package or two to my project with the namespaces and the assemblies that I need to talk to the Office 365 Outlook Services client. Now if I come over to my project, one thing I want to do before I get too far along is to grab the HTTPS endpoint, and I'm going to copy this and then come back to the properties for my project, and I'm going to set the startup property to say the start URL should be equal to this HTTPS endpoint, which it already is set, so that's good. Now let's go over to our web config and make sure we have all the values that we need. So we can see the client ID has been set, as has a password. We need our Azure AD tenant ID. Well, I went ahead and grabbed that ahead of time, so I'm going to go ahead and paste this value right inside of this Azure AD tenant ID. Okay, so everything is now set up correctly, and we should be in good shape. So let's build our project. There we go. So we can see that everything works. So that's how simple it is to go create an Azure AD to add a connected service to an existing MVC application. We can also see we have references to Office 365's Discovery service and the Outlook services namespaces as well. And these were all added using a specific project, specific NuGet package that we'll find right here. The Outlook Office.365.discovery and Office 365.discovery services packages. Now let's look at the paging support that we have inside of the Outlook Services client. Now I showed you this code just a minute ago. Now what you see here, I want you to take note of how the query is being written. What I'm going to use is the skip and the take methods to jump to a specific page and then grab a page of data. But what's important is that I use skip and take before I call execute async. The reason for this is that if I call it this way, the skipping to a specific page of data and then taking a page of data back is going to cause all the paging to occur server side on the Office 365 servers. If I call skip and take after execute async, what's going to happen is it's going to go get all the data and pull it down to my application and then go find the specific page it needs and then discard all the other data. That's grossly inefficient. So you want to make sure that you call execute async after you set the paging up. Second of all, if there's more data available, there's an extra property that will be returned called more pages available that will let you see if we need to create another, like a little visual indicator for the next page of data. So let's look at how paging works with the Outlook Services client. Now let's see how we can get data back from using the Outlook Services client for email. So if I come over here and I look at my controllers, I'll see that I have a controller called the Mail Controller. And let's see what this does. The Mail Controller is creating an instance of something called My Messages Repository. That's a class that I created. We'll look at that in just a minute. The initial action is for index, and that's when I go to the home page of the application. So here's the index, and I'm looking at a page number that's being passed in. It's an optional parameter. You must be authenticated to be able to get to this endpoint. Here I'm going to get a list of all the different messages that are out there. So I'll say _repo/messages, and I'm going to get a specific number of pages of messages back. You can see that I actually get a property that comes back on my repository that's set to say there are more pages available, and that's going to be helpful for paging. So let's see how this works. I'm going to right click on this guy and go to the declaration of this method. So we see here, there's my get message, my messages repository. I have a public property on this called My Pages Available. So there's my public Boolean value that I'm going to be able to use to see if there are additional messages or additional pages of data. Here I'm going to call get messages. Now the first thing I do is I call ensure client created. And I went through this in the slides, but this is a method that's inside this class. And what it does is it authenticates and uses the directory service to go fetch the endpoint and the resource ID for the mail endpoint, and then it uses those two values to get an access token for the mail endpoint. Then it's going to create an Outlook Services client. So I have my Outlook Services client here that I can use to query for mail. Now what I'm going to do first is I'm going to write a query here. And the query is going to say, from each message in the client.me.messages, so look at all my email, sort them in descending order when the time was sent, and then select the message back out. When I call execute query async, it'll go grab all of the messages sorted in descending order from my mailbox. It'll also set if there are any additional files left or any additional pages of data left. It'll indicate that using the more pages available property. And then I'm taking all the code, all the messages that came back, and I'm converting it to my own object here called the My Message object, which I'm adding into my own collection. And then I'm going to return that collection back to the caller, which is what I'm going to use in my views. Now it's worth noting here that I'm actually doing a little bit of paging. So you see here that I'm using take and skip. Skip says skip to the specific page of information that you're interested in. Take says only grab a certain number of items back. So in this case, let's say I was on page 4 and I wanted 10 items per page. Skip would say, start at item number 40, skip the first 40 items, and starting at item 41, grab the next 10 items. And that's where skip and take come into play. Because these are before execute async, what they're going to do is these are going to do the paging on Office 365 and only return back that one page of data from Office 365. If I had the execute async above these two, like this would be a bad style, because what would end up happening with this code right here is it would actually go execute my code first, and then it would start grabbing just a specific page. So that's definitely not what we want. So here I could run this and get all my messages. Now let's talk a little bit about batching. Now the .NET objects that we have allow us to do some batch operations, but when we're working with REST directly, we can't go through and each REST request is going to be submitted as a separate request. That's every single insert, delete, update, and get request. Requests can be slow, and they can really slow our application down. And so you want to make sure that you don't set up the application so that it's going to there's much more performance. You want to batch your requests up if possible. Office 365 REST APIs shipped with support for batching with the REST APIs. Batching requests was also added to SharePoint Online in SharePoint Online in 2014. You can send multiple read and write requests in one batch request. However, SharePoint 2013 on-prem does not support this. Let me say this whole slide again. Batching support was added to Office 365 REST APIs when they shipped in late 2014. In addition, batching was also added to SharePoint Online in 2014 as well. This is going to allow us to send multiple read and write operations in one HTTP request. However, this is not supported on SharePoint 2013 on premises at the time of this recording. Let's look at the impact of this. At the top, you see 3 requests. Sessions 1 and 2 are creating new items on a drivers list, and session number 3 is getting data back from that list of all the drivers that are there. Those are 3 different round trips that I'm making to the server, and they're all happening in sequence. Well, one of the things I can do is I can batch those requests together, as you see in session number 24. That contains one big request that's going to reach out across the wire, pass in these 2 different requests to create items, and then another request to get items back, and we'll get one single response back. It has even a bigger impact when you're deleting a bunch of items. So here I'm deleting 6 items, which is 6 individual round trips, followed by a single get. You can see how that can all be compressed down in session number 28 by issuing all 6 of these and the single get requests, so 7 requests in one round trip on session 28. So what does it look like? Well, you're going to create a batch request, and this is going to be just one big submission to the batch endpoint. Inside of this request, you'll have multiple chain sets, one for each thing that you want to do that's a non-get request. You'll also have an HTTP GET request at the very end. Now that's not required, this is just an example. All of this is wrapped up in a single batch request. The response that comes back is an object, is a response object, and you'll have a single change set response for each change set that you submitted, coming back in the exact same order that you submitted them. And then you'll have a final one for getting the responses back as well, that from your HTTP GET request. Let's talk about some CRUD support with the REST API. We can get and delete specific entities by calling the client.me.messages.getById to get a specific item back. To delete an item, you would just call delete async on that item after you've obtained it. Let's say you want to send an email. So to send an email, what you're going to do is you're going to create a new object. Now this is a message object that's coming from the Office 365 namespace. I'm going to create the message that's going to specify the subject when I create it. I'm then going to create a new email address object. And this is a to recipient. So when I do this, what this is going to do is the email address object has a name and an address property. I'm then going to set the to recipients collection. I'm going to add that recipient and pass in the email address that I created. I'm then going to set the body of it. The body can be either of type text or HTML. And then I'm going to call on the messages collection, add message async, and pass in the message, and then say new message.send async, and it will submit that message. Let's look at some of these operations in a demo. In this demo, I'd like to show you what the code looks like for deleting and sending emails. To delete a message, what you have to do is first get a reference to the Outlook Services client, and then you're going to get a specific message back from Outlook. So here I'm saying client.me.messages, get by ID and get the specific ID of the message that's requested, and then I'm going to call execute async to go get that message. I'm then going to call delete async to delete the message. When I want to send an email, I'm going to create a new message object. This message object is coming from the Office 365 namespaces. So I'm creating a new message and setting the subject, and then creating an email address. An email address has two properties, the name and the address itself. And I'm going to add that to the to recipients collection of emails. I'm going to set the body to be of type text, and then set the content of the body. And then I'm simply going to send the message by saying add the message asynchronously to my messages collection, and then I'm going to tell Exchange to go ahead and send that message. And that's all there is to deleting and sending messages. Now I can also do a lot of these operations using REST. If you look at the first block of endpoints here, these are examples of the different endpoints you would call to submit messages using the REST APIs. They're all going to be done using the outlook.office365.com endpoint, and then you go /API/v1.0/me, and then it just depends on what you want to get done. You can look at a collection of messages, you can look at a collection of your folder, the root folder, you can get a list of all the messages within a folder, you can look at the drafts folder, the sent items folder, and the deleted items folder, which are all special folders. To read an entity with REST, you're simply going to use one of those URLs I pointed to at the beginning. Notice that we're using the skip and top OData operators to get a specific page of data. A little bit farther down, you can also see we're using the authorization header to specify the bearer token to get the data back. In this case here, I'm using a little utility function called JSON to XML that'll convert the JSON response over to XML so I can use an XElement object to get the data out of the response. To create a new entity, I'm going to have to do an HTTP post to submit the data over to SharePoint. To create a new entity, I'm going to use an HTTP post to specify the endpoint for all the different operators. So in this case here, I'm showing you for contacts, but messages would be worked the exact same way, where I would create a message to submit data back using JSON. Here I'm using the authorization header, and I'm using an HTTP post that you can see there in the creation of the request message. I can also delete an entity by getting a reference to the specific item endpoint, and I can do that after getting a list and finding out all the different items that are there, and then submitting that as an HTTP delete to that endpoint. So let's take a look at some of these operations using the Office 365 REST APIs. In this module, we looked at an overview of what we can do with the Office 365 Mail API. We looked at connected services, paging support, batching support, and the support we have for doing create, read, update, and delete operations with the .NET SDK. Finally, we looked at some of the operations that we can do using the REST API. Microsoft offers multiple ways to get in touch with them and also to stay up to date on what's going on. One of the things is the developer program launch. What the developer program is all about is allowing you to sign up and get email newsletters, free developer subscription to Office 365, which will give you a 1 year free to a Office 365 tenant, free training, free tools, and free webinars that they'll publish on a periodic basis. Using this developer program, you'll be able to stay in touch and up to date with all the latest and greatest offers and news and updates coming out of Office 365 and Office development. You can sign up for it at dev.office.com/dev program. The Office team also provides multiple ways for you to sign up and to stay in touch with what's going on. From the Office 365 network and Yammer, to staying in touch on Twitter using the Office Dev handle. You can also ask questions on Stack Overflow using the tag ms-office. We have multiple podcasts as well. If you go to dev.office.com to sign up for different podcasts, such as the Office 365 Developer Podcasts. In Channel 9, there's a developer show as well, the Office 365 Developer Show, that comes out on a weekly basis. You can also find out about a bunch of different tiny little quick snack demos of quick demos. You can find those at YouTube if you go to aka.ms/o365devsnackdemos. And then finally, do you have feedback for the team? Do you have ideas for new features? Do you have changes that you'd like to see implemented? Submit them on UserVoice by going to officespdev.uservoice.com, where you can submit your ideas, and then you can also vote on other people's ideas and provide comments to the team. The engineering team looks at these issues on a periodic basis and a regular periodic basis and triages them to look to improve them and add things to the product going forward. Thank you very much for taking a few minutes of your time to watch this screencast.